SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe. You can download SpaceTime as a free twice-weekly podcast just about everywhere, including iTunes, Stitcher, Pocket Casts, Bytes.com, YouTube, SoundCloud, Audio Boom, and from spacetimewithstuartgary.com. The show's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C. Coming up on SpaceTime, confirmation that the Tunguska impact event was probably caused by an asteroid airburst, giant cannonballs seen shooting from a star, and Australia's new NBN telecommunications satellite launched into orbit. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Scientists have finally confirmed that an asteroid caused the Tunguska impact event in Siberia in 1908. The findings, reported in the journal Planetary and Space Science, are based on tiny mineral samples of debris from the Tunguska impact zone that are characteristic of a meteorite. While a meteor airburst over the remote Siberian site had long been the prime suspect for the disaster, both a comet impact and an explosive volcanic rupture from the Earth's mantle had also been suggested as possible sources. The Tunguska event occurred on the 30th of June 1908. Exploding with a force of 3 to 5 megatons, the equivalent of 1,000 Hiroshima bombs, the event lit up the night sky in London a third of the way around the globe with an orange glow, and it was clearly picked up on seismographs thousands of kilometres away. But it took 19 years for a scientific expedition to finally reach the remote location on the Tunguska River in Siberia where the explosion occurred. What the scientists saw was a landscape of utter devastation, even though the event had occurred almost 2 decades earlier. The blast had flattened some 80 million trees over an area of more than 2,000 square kilometres. Mature trees had been snapped off at their bases, covering the ground for hundreds of kilometres like matchsticks, and all pointing away from the main impact site, thought to be the location of what is now Lake Chico. Computer simulations indicate the only thing that could have caused such devastation over such a wide area was the airburst of an object between 1 and 200 metres across. Now, scientists have examined mineral debris trapped in the pit from the blast area which was collected in the 1970s and 80s. Using high-resolution imaging and spectroscopy, the authors were able to identify polycrystalline aggregates of carbon minerals, diamond, lonsdaleite and graphite. Nanometer-sized particles of lonsdaleite formed together with diamond and graphite particles in carbon-rich material that suddenly hit by a shockwave through an event such as a meteor impact. The authors also found iron-nickel alloys, trollite and taenite, together with tiny inclusions of iron sulfides, all of which are also often found in meteorites. The mineral composition found in the Tunguska pit appears to be the microscopic vestiges of what was the largest meteor impact in recorded history, and very similar in composition to that found in the Canyon Diablo meteorite, which produced Arizona's famous Beringer impact crater, better known to most people simply as Meteor Crater. Now, if it was an asteroid which airburst over Tunguska, and that's certainly what the evidence is showing, then it may well have come from the Beta Taurids meteor shower, a debris trail from the comet Encke, which the Earth passes through every June and November. Astronomers have detected mysterious superhot balls of ionized gas or plasma, each almost the size of the Earth, being shot into space from near a dying star. The fireballs, reported in the Astrophysical Journal, were detected moving through space at around 800,000 kilometres an hour. So quickly, in fact, that they could fly from the Earth to the Moon in just half an hour. The authors estimate this stellar cannon fire has continued once every 8.5 years for at least the last 400 years. The fireballs present a puzzle to astronomers because the ejected material could not have been shot out by the host star V Hydra. The star is a bloated red giant located some 1,200 light-years away in the constellation Hydra. Red giants are dying stars, no longer on the main sequence. That means they no longer have core nuclear hydrogen fusion occurring, the process which makes stars like our sun shine. Instead, red giants are cool, bloated, gaseous stars, shedding mass into space as they go through their final death throes. The astronomers think the superheated plasma balls they're seeing being fired into space are actually coming from an unseen binary companion star. This companion star is thought to be in an elliptical orbit, which brings it close to the red giant's puffed up outer atmosphere every 8.5 years. As the companion enters the red giant's outer atmosphere, its gravitational pull collects some of the red giant's gaseous envelope. This material forms an accretion disk around the companion star. The buildup of material on the accretion disk reaches a tipping point and is eventually ejected into space as blobs of hot plasma along the star's spin axis. Now, if they're right, this star system could well be the archetype to explain a dazzling variety of glowing shapes known collectively as planetary nebula that are often seen around dying stars. A planetary nebula is an expanding shell of glowing gas expelled by a red giant towards the end of its life. Eventually, with the gaseous envelope gone, all that's left of the red giant is the star's exposed white-hot stellar core, called a white dwarf. The study's lead author, Raghvendra Sahai from NASA's Jet Propulsion Laboratory in Pasadena, California, says he knew the object had a high-speed outflow from previous data, but this was the first time his team were able to see this process in action. Sahai thinks these gaseous blobs generated during the late phase of a star's life helps produce the structures often seen in planetary nebula. Observations by NASA's Earth-orbiting Hubble Space Telescope over the past 2 decades have revealed an enormous complexity and diversity of structure within planetary nebulae. Hubble's high resolution has captured knots of material in the glowing gas clouds surrounding dying stars. Astronomers have long speculated that these knots were actually jets ejected by disks of material around companion stars that weren't visible in Hubble images. And that sort of makes sense, because most of the stars in the Milky Way galaxy are members of binary star systems. But the details of exactly how these jets were produced has long remained a mystery, at least until now. Sahai and colleagues wanted to identify the process that causes these amazing transformations from a puffed-up red giant to a beautiful glowing planetary nebula. These dramatic changes occur over periods of roughly 200 to 1,000 years, literally the blink of an eye in cosmic terms. Sahai's team used Hubble's imaging spectrograph to conduct observations of V Hydra and its surrounding region over an 11-year period, initially from 2002 to 2004, then again from 2011 to 2013. Spectroscopy is an important tool in astrophysics because it decodes light from an object, revealing information on its composition, velocity, temperature, location and motion. The data showed a string of monstrous superhot blobs, each with a temperature of more than 9,400 degrees Celsius. Now that's almost twice as hot as the surface of the Sun. The Hubble data shows how some blobs that have just been ejected have only moved a little way from the binary system. Other blobs that were ejected a while ago have moved much further away, while still other blobs ejected ages ago are much further away again, as far as 60 million kilometres from V Hydra. That's more than 8 times further away than Pluto is from the Sun. The blobs expand and cool as they move further and further away. But observations taken at longer submillimetre wavelengths in 2004 by the Submillimetre Array in Hawaii revealed fuzzy, knotty structures that may be blobs launched from the same system more than 400 years ago. Based on the observations, the authors have developed a model of a companion star with an accretion disk designed to explain this ejection process. This model provides the most plausible explanation because scientists already know that accretion disks can and do generate jets of material. While red giants don't have accretion disks, many do have companion stars, which presumably have lower masses because they're evolving more slowly. Now, this model can help explain the presence of bipolar planetary nebulae, the presence of knotty jet-like structures in many of these objects, and even multipolar planetary nebulae, so it has very wide applicability. One surprise from the study was that the accretion disk doesn't fire these monster clumps in exactly the same direction every time. Instead, the direction tends to sort of flip-flop slightly from side to side and back and forth due to a possible wobble in the accretion disk. While surprising, this discovery helps explain some other mysterious things that have been observed about this star. See, astronomers have noted that V Hydra is obscured every 17 years. It's as if something was blocking its light. That could be due to the back and forth wobble of the jet direction. The blobs alternate between passing behind and in front of V Hydra, and when the blobs pass in front of V Hydra, it shields the red giant from view. The authors say the accretion disk engine must be very stable. Because it's been there such a long time. It's been launching these structures into space for literally hundreds of years without falling apart. And that's interesting, because in many of these systems, the gravitational attraction can cause the companion star to actually spiral into the core of the red giant. Eventually, though, the orbit of the Hydra's companion will continue to decay, because it's losing energy in this frictional interaction. However, the authors admit they don't know the ultimate fate of the companion star. The team hopes to use Hubble to conduct further observations of the V-Hydra system, including the most recent blob, which was ejected in 2011. The astronomers also plan to use the Atacama Large Millimetre Submillimetre Array Telescope, ALMA, located in Chile, to study blobs launched over the past few hundred years that are now too cool to be detected with Hubble. SkyMaster 2, the second of two new NBN telecommunications satellites, has been successfully launched into orbit aboard an Ariane 5 ECA heavy lift rocket. Arianespace mission number VA231 blasted off into late afternoon skies from Launch Complex ELA-3 at the European Space Agency's Kourou spaceport in French Guiana. The launch had been delayed by several hours due to high winds above the South American spaceport.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage Vulcain, allumage AP, décollage. Les paramètres à bord sont nominaux.
It's an e-ticket ride tonight as we rumble the Amazon jungle. The mighty Ariane 5 ECA roars into the sky over Kourou. 49 seconds into the flight, Ariane 5 has already broken the sound barrier here in Kourou. The massive Jupiter facility will be shaking momentarily as the launcher roars out over Devil's Island, made famous by the movie Papillon. 1,300 tons of thrust breaking the Ariane 5 free from the Earth's gravity. 90% of that power coming from the two boosters, each one 31 meters tall and burning 240 tons of solid propellant in 2 minutes, more than 2 tons per second. Now we feel the rumble here at Jupiter. When the boosters have done their job in less than a minute, but now Ariane will be 70 kilometers in the sky, traveling at more than a mile a second, faster than a bullet. The data is coming to us from Gilat, a tracking station on a big hill. Behind us, 2 minutes into the flight, Ariane 5 roars into the sky over Kourou. All is going green. The next big thing will be the burnout and the jettison of the twin solid rocket boosters. That will occur about 3 seconds from right now.
Séparation des étages d'accélération à poudre.
The two boosters falling away and the main core, the Ariane 5, and our two passengers making its way into the heavens. The boosters have done their job. We don't need them anymore, and they will fall into the ocean. We've lost 600 tons in just 2 minutes. The Ariane 5 weighs about 180 tons now. As Ariane gets lighter, it goes faster, and all is going well at 3 minutes and 8 seconds into the mission. The next big event will be the jettisoning of the fairing. It will be gone in just a few seconds.
Séparation de la coiffe.
And there it is. Its job is done. It has fallen off about 100 kilometers into the sky. That's 17-meter fairing. We have lost 2.4 tons again. And again, the DDO says everything is normal. The launcher now 121 kilometers into the sky. The main cryogenic stage, or the EPC, is now burning. It burns for about 9 minutes. The EPC is really just a huge fuel tank. It carries 150 tons of liquid oxygen, 25 tons of liquid hydrogen. That engine is gulping 320 kilograms, about 700 pounds of fuel every second, 500 times more than a jet engine. And this is the 5th Ariane 5 launch of 2016. We began the year with a single satellite launch on 27 January 1st. for Ariane 5. 9th of March, we did it again. We also had dual launches on 18th June and on the 24th of August. Plans call for the Ariane 5 to fly 2 more missions before the end of 2016. Tonight will be the 74th success in a row for the Ariane 5. Tonight, we will tie the record of its predecessor, the Ariane 4. While both of them are now tied, the Ariane 5 has a dramatic advantage because of its size and power. It has successfully launched 24 more payloads, totaling almost 350,000 kilos more than the historic Ariane 4 rocket. We're right on track, and the rocket is now 160 kilometers above Earth, riding that pillar of power. The final target number for speed tonight, by the way, 9.3 kilometers per second. A few more interesting facts for you. NBN SkyMaster 2 and GSAT 18 represent the 533rd and 534th satellites to be launched by Arianespace. They are also the 123rd and 124th satellites to go into geostationary transfer orbit by the workhorse of the fleet. That's the Ariane 5 that debuted here in 2002. All continues to go well. Very shortly, the launcher will be acquired by the Natal tracking station in Brazil. Tonight we use Galiet here in Kourou on a big hill right behind us. Natal in Brazil, a station on Ascension Island in the middle of the Atlantic Ocean, and then Libreville on the west coast of Africa, and Malindi, Kenya on the east coast of Africa. And coming up in about 10 seconds, we will be picked up by that tracking station in Natal, Brazil. Ariane sends data to these ground stations, tells us how the flight is progressing in real time. Later, engineers are going to pore over every single bit of that data to determine exactly how the vehicle performed every step of the way.
The 54.8 metre tall ECA is the most powerful version of the Ariane 5 launcher and is designed to deliver payloads weighing up to 10 tons into geostationary transfer orbits. SkyMaster 2 was deployed into its geostationary transfer orbit 28 minutes and 26 seconds after launch. Built by Space Systems Loral in Palo Alto, California on an SSL 1300 platform, SkyMaster 2, or NBNCO-1B to use its formal title, is a 6.44-ton spacecraft equipped with 202 Ka-band focused spot beam transponders designed to concentrate signal coverage to specific remote regions of the Australian outback. The spacecraft's 2 deployable solar arrays and batteries will generate up to 16.4 kilowatts of onboard power. Together with its identical twin, NBNCO-1A or SkyMaster 1, the satellites will provide high-speed broadband services at 80 gigabits per second to some 400,000 home and business customers in remote rural and outback areas. SkyMaster 1 was launched on an Ariane 5 from Kourou on October 1, 2015. Both satellites are in geostationary orbits at altitudes of 36,000 kilometres above the equator, and both carry enough fuel for a 15-year lifespan. NBN says its new bird will now undergo several months of in-orbit testing before commencing its service life and extending NBN coverage to new areas, including the Norfolk, Christmas, Macquarie and Cocos Islands. As well as the SkyMaster 2 satellite, the flight also carried India's new GSAT 18 telecommunications satellite, which was deployed 4 minutes and 7 seconds after SkyMaster 2. Built by the Indian Space Research Organisation, the 3.4-ton GSAT 18 carries 24 C-band, 12 extended C-band and 12 Ku-band transponders. The GSAT 18 was originally slated to launch on July the 12th alongside Japan's Superbird 8 telecommunications satellite. However, a shipping mishap which damaged Superbird 8 forced a delay in the launch schedule. The flight was the 233rd launch of an Ariane vehicle from the Kourou spaceport and the 8th of 12 flights planned for this year by Arianespace. It was also the 88th launch of an Ariane 5 rocket and the 5th Ariane 5 flight this year. Arianespace's next flight, slated for November the 17th, will launch 4 European Space Agency Galileo navigation satellites, also using the Ariane 5. Blue Origin have successfully tested the launch abort escape system for the company's New Shepard rocket. The test at Blue Origin's West Texas launch facility involved the spacecraft blasting off from the pad and the crew capsule escape system being suddenly activated at max Q, the time of maximum aerodynamic pressure on the spacecraft, which in this case occurs about 45 seconds after launch at an altitude of about 16,000 feet. The single abort motor was fired for just 1.7 seconds on the base of the capsule, while at the same time the emergency separation system was activated. The procedure successfully rocketed the capsule well away from the launch vehicle. The capsule's reaction control system was then used to stabilize its orientation, causing it to coast to a safe position where 3 drogue parachutes were deployed, allowing the capsule to descend safely back to Earth, touching down 4 minutes and 15 seconds after liftoff. Amazingly, the launch vehicle, which wasn't expected to survive the extreme stresses placed on it during the test, managed to land safely 7 minutes and 38 seconds after liftoff. This latest abort test was conducted just 3 years after Blue Origin undertook a launch pad abort test, which involved the capsule being rocketed away from the launch stand in the event of a catastrophic launch vehicle failure. The test was the 5th flight for the New Shepard vertical takeoff and landing spacecraft. The spacecraft's designed to eventually take passengers and scientific payloads on suborbital ballistic flights to altitudes of over 100 kilometres or 328,084 feet, the official start of space. And that's the show for now. You can subscribe and download SpaceTime as a free twice-weekly podcast through iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, and from SpaceTimeWithStuartGary.com. The show's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C.
This is SpaceTime with Stuart Gary. For more, you can follow us on Facebook, Twitter, and Tumblr. Just search for SpaceTime with Stuart Gary.
SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine. This month, looking at whether the next generation of supercomputers will be able to handle the mega streams of data expected from the next generation of giant telescopes like the Square Kilometre Array.